my submission for the second lab assignment for visualization. I am visualizing the PUBG dataset, which is an open source dataset hosted on Kaggle. So as you can see, the server is already running, and this is the front end. The front end is written using JavaScript, HTML, and utilizes the D3 framework, whereas the backend is written using Python, which utilizes the Flask framework. So this is the plot elbow method. Here we are actually plotting the mean square distance versus the number of clusters. So we see that the elbow is at 3, which means that 3 is the optimum number of clusters. This is utilized for stratified sampling, and the function used here is getNy, which actually gives us the optimum value of k. Going ahead, this is the scree plot for stratified sample data. As you can see, we used k equal to 3 for sampling the dataset, and this dataset also gives us the number of components versus the eigenvalues. We can see that there is an elbow at number of components equal to 4, and this is also found out using the getNy method in Python. We can also see the plots for randomly sampled data and for the original data, all of which are almost equal and have the elbow at n equal to 4. Next, we move on to plot PCA. So here we are plotting the principal components, that is component 1 versus component 2 for stratified sample data. As you can see that the drop down actually has a function called as choose task, which actually sends the requests back to the backend, and the backend then processes all of the requests. As you can see here, it gets the requests and it sends the data back to the front end. The set opt function actually is used to set which type of data set is to be used for plotting. It can either be stratified sample data or the original data or randomly sampled data. So it actually reduces the amount of code that I need to write. This is the code for plots scree. As you can see, most of the values are clustered in between -2 and +2, although there is no significant correlation between any of the two components. And it happens the same for all of the data sets. Using multidimensional scaling actually takes significant amount of time, so we'll wait for now. Here is the plot of the data using multidimensional scaling. Even this plot actually tells us that most of the data is cluttered between low values and actually has high variance uh, in the component 1 axis. We'll now hop on to MDS using correlation on stratified sample data. Then we move on to plotting the scatter matrix. As you can see, for stratified sample data, this is the scatter matrix, The top three PCA loadings are for the attributes swim distance, walk distance, and kill points. And we can see that there is hardly any correlation between any of the three attributes, which is actually stating that the data is pretty much random, and it cannot be. Also, you can see that the attributes are changing. Here we have attributes as weapons acquired, swim distance, and longest kill for the original data, whereas for the randomly sampled data, they were different. It was weapons acquired, ride distance, and match duration, which also states that there is some amount of bias when we are sampling the data. You can see the attributes change significantly. When viewing the original data, we can see that the longest kill and weapons acquired actually have a small connection, which says that uh, when the weapons acquired are a bit more, then the longest kill actually also varies, which is pretty much common sense. Yeah, that's it. Thank you.